Okay, I'm gonna do my best to make a DIY unit circle lesson here. So, stole some construction paper from my grandson's art cabinet, and you're gonna need something round that you can use to trace. So this is the lid from a coffee can in the kitchen, and you're gonna wrap around this circle here um, the best that you can if you're playing along. And then you'll need some scissors, and you want to cut out at least four circles. It doesn't matter if they're different colors. It's just easier to see if they are different colors. But you do want to make sure that they're as perfectly round as you can get with the supplies that you have at home. So had we been in school still, we would have done this or something similar in class, but apparently the videos that I found online for the unit circle are not hitting the spot for most, so we're going to give this a go. Because of how long this takes, we usually do this for several days in class. I'm going to try to break this up into a few different video segments, so you can skip around if you need to. But let's see. So if we start with one of these, this will be our base circle. And we kind of did this with the paper plates in class, but the idea here is just to get a feel, and we're going to focus in radians since that's what most people have the hardest time with. But we're going to try to get a feel for how the radians are going to make up this circle. So if you fold your circle in half, remember a whole circle has 2 pi radians. That's the circumference of the circle, 2 pi r, and a unit circle has a 1 as its radius. So 2 pi times 1 is 2 pi. So 2 pi radians in the whole circle. So if we fold that in half, now that means that we have a semicircle. That's 1 pi, right? 1 pi radians angles. And if I fold that half in half, then that's going to be 4 sections of the circle. So this angle that we're looking at, which in degrees, that would be 90 degrees. It's a fourth of the circle. But in radians, since there's 2 pi radians in the whole circle, a fourth of that would be, let me get my whiteboard here. So this size angle, which is 90 degrees, that would be 2 pi in the whole circle divided into 4 sections, means that this angle is, this reduces to a 1 and a 2, so 1 pi over 2, or pi over 2 radians. Okay, so this angle, 90 degrees, is the same as pi over 2 radians. Half of that circle, right, since the whole circle was 2 pi, okay, this much, which in geometry we would call a straight angle, that's 180 degrees in degrees, but in radians, the whole circle was 2 pi. We divide that in half, right, that cancels, and this is pi radians, that angle up there. Now, if I take that circle that I started with now, and I'm just tracing along the fold lines that I made so that I can count around this circle and see what I've got so far in radians. So if this is my origin, 0, 0, and then this is 1 unit across, then this would be the point 1, 0. And that's where I'm starting, is the point 1, 0. So this is 0 radians. Then as I go up here, that was 90 degrees, which we just saw is pi over 2 radians. Then as I come back around down to here, this is half of the circle, which is pi radians. Then if I follow this pattern as I count around the circle, this is 0, 1 pi over 2, 2 pi over 2. So this one down here would be 3 pi over 2 radians. Then back around 4 pi over 2, which is the same as 2 pi. So when you divide up a circle with a radius of 1, you've got pi over 2, pi, 3 pi over 2, 2 pi radians, dividing up your circle into 4 pieces. Okay, so now if I take another layer, and instead of dividing this circle into 4 pieces, I'm going to carve it into 8. So if I fold it in half, right, that takes my 2 pi in the whole circle and brings me just to 1 pi radians. I fold that half in half, and now I have my pi over 2 angle, right? So there's pi over 2 radians in this size angle, which if I put it back on my original circle, see how it fits? Right there is my pi over 2 radian size angle. Now if I take that and I fold it in half, I'm cutting pi over 2 in 2. So this is the size angle now that I'm looking at, and that's going to be half of a half, which in written out form, we're going to take 1/2 and we're going to times that by 1/2 because we want half of a half, and that's going to be 1 times pi over 2 times 2, which is 4. So this size angle, this green one right here, is pi over 4 radians. That's what pi over 4 looks like. And there are 8 of those in the whole circle. So as I unfold this pi over 4 angle, right, this is 1 pi over 4 that I'm currently looking at. Now this is 2 pi over 4 if I draw that dividing line. So 1 pi over 4, 2 pi over 4 makes up my pi over 2 angle. That's my first quadrant. If I go another piece out, so let's see if I can do that without making a mess. Okay, now I have 1 pi over 4, 2 pi over 4, 3 pi over 4. Okay, if I unfold one more layer, now that's going to be 4 pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, which is half a circle. And 4 pi over 4 is pi, right? So that makes sense, half a circle. Now, if I continue that as I go around, there's going to be 8 sections altogether when I divide up the circle into this size of segments, or sectors, I guess they're called. So as I trace each of them going down here, right, this is my center of my circle, 0, 0. And now that I've carved my circle up into 8 pieces, I'm going to first erase this so it's out of my way. So I'm going to count around the circle like I did with the first one, the yellow one, and label these angles. So starting at 0, 0, this is the origin. This is 1 unit away, so 1, 0. I start counting at 0 pi over 4. Okay, 1 line over, that's going to be 1 pi over 4 radians. Okay, then the next one is 2 pi over 4, and that reduces to pi over 2. So up here is pi over 2, right? 0 pi over 4. Now 2 pi over 4 is pi over 2. One more over, that's going to be 3 pi over 4. Then I have 4 pi over 4, because I'm counting 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. 4 pi over 4 reduces to pi, and that's half the circle. So I've got 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. That makes this one 5 pi over 4. Then 6 pi over 4 is going to be down here at 3/4 of the way around is 6 pi over 4, but 6 and 4 are both even. So that reduces to 3 pi over 2, right? Those are equivalent. Then I keep going. So 1, 2, 3, 4, 5, 6. That makes this one 7 pi over 4, which doesn't reduce. And then back to where I started from at the beginning of my circle with 2 pi, that's 8 pi over 4, which reduces to 2 pi. So if I lay my yellow circle, the one that was divided up first, on top of this green one, do you see how the pi over 4 segments, they reduce down into, at the quadrantal angles, what we originally said with the yellow circle, right? The pi over 2 matches. That's the same as this 2 pi over 4 from when we chopped it into 8 sections they correspond, right? These quadrantal ones, which is kind of cool. Okay, now if instead of chopping up my circle into 8 sections, what if with a new color, now we're going to chop up our circle into 6 sections. So first we're going to take our 2 pi in the whole circle, fold that in half, and this is going to be 1 pi. Right? A semicircle is 1 pi, but I'm not going to fold it in half again, okay, because I want to get 6 sections. That means I need 3 on the top half of the circle and 3 on the bottom half of the circle. So this can be a little tricky. If you have a protractor, just measure out 60 degrees, but if you don't, you're going to ever so carefully try to fold this into thirds, because we're taking basically 180 degrees and dividing it by 3, which is 60. So we need 3 congruent sections here to be 60 degrees, and that is no easy thing with construction paper that's pretty old. So let's see how we do here. And that's not too bad. Okay, so no promises, but that looks about right. Okay, so if I put this on my circles here that I made earlier, right, the yellow one, this was cut into 4 pieces, or not cut, but folded into 4 pieces. Each one was pi over 2, right? 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. If I lay this pi over 6, or sorry, pi over 3, because it has 6 sections in it, right? Do you see how 1 pi over 3, right, fits right there in the first quadrant? 2 pi over 3 would be here, and then 3 pi over 3 gets me to here, which is the first half of my circle. 3 pi over 3 is 1 pi. So by unfolding this and drawing my fold lines on, I should be able to get a sense of how the carving the circle into 6 sections will look. So this is 1 pi over 3 right here. So here's my 0, 1 pi over 3. Then this was 2 pi over 3 right here. See how it goes past the middle where the pi over 2 was? We skip right over that. So 1 pi over 3, 2 pi over 3. Then as I unfold another third here, now I trace along that fold line, I've got 3 pi over 3, which reduces to pi, right? See how those match up? 3 pi over 3 is pi. Now if I take the bottom half now and carry that through, then this one, right, that's 1 pi over 3, 2 pi over 3, 3 pi over 3. This one's going to be 4 pi over 3. Then this is 6 pi, or no, sorry, 5 pi. Forgot how to count. 5 pi over 3. And then back around to where I started is going to be 6 pi over 3, and 6 over 3 is 2. So see how 6 pi over 3 reduces to 2 pi, which matches what we had on our first yellow circle. So this is going around our circle if we divide it into 6 sections. So again, 1 pi over 3, 2 pi over 3, pi, 4 pi over 3, 5 pi over 3, 2 pi. Okay, so we've got a circle divided into 4 sections. This one was 8 sections, and this one is 6 sections. Okay, now we still need to do one more to get all of the special angles on the unit circle, and that's if we divide this this monster into 12 sections. So 6 on the top, 6 on the bottom. Okay, so if I fold this 2 pi in the whole circle, fold that in half, now we have 1 pi. Okay, then if I fold that into half, is that right? Fold that half in half? Yeah, that's right. Okay, fold that half in half. So now I've got 2 on there. And then I need to, and this is hard to do if it gets too thick, so I'm going to try to do it with just this one side. But I need to take this half now of that half, so I guess it's a quarter, and get this cut into 3 sections. So I'm basically taking 90 degrees and dividing it by 3, which is going to give me 30-degree sections, 12 of them around my whole circle. So I'm going to try to do what I did with the orange layer here and fold this into thirds, but only that one quadrant. So this one is a little trickier than even that last one was. It's a little bit too big. There we go. I think that's pretty close. Okay, so this would be, if I trace that fold line here, that's going to be about what 30 degrees looks like if I cover up that part. Okay, that's 30 degrees-ish. That should be, if I did it right, it should be half of one of these orange sections, because those are pi over 3, and this one, if there's 12 of them, 30 degrees would be pi over 12. So if I lay that, like, see if I can line it up here with my axis, and that's not too terrible, right? That looks like about half of that orange space. So one of these purple sections is going to be 1 pi over 6. 2 of them will fit in a pi over 3, which was the orange areas here. So 2 pi over 6 fits inside of 1 pi over 3. Okay, so if I trace this section, right, that's going to be what 1 pi over 6 looks like. And in the top half of my circle, let's see if I can get this out of the way. Okay, now if I'm starting at 0, again, this is 0, then one of those purple will be 1 pi over 6. The next one is going to be 2 pi over 6, which if I bring back this orange circle and line them up, right, here's my zeros. See how 2 pi over 6 matches up and reduces to the pi over 3. Okay, then next, so I've got 1 pi over 6, 2 pi over 6. Next comes 3 pi over 6, and if I slide that down, I need the orange or yellow. There we go. If I slide that down from my yellow, right, see how that matches up with pi over 2. So 3 pi over 6, right, is the same as pi over 2 when I chop up my circle into 4 pieces. Okay, then after that, 3 pi over 6, oh, I didn't fold those in. Hold on, gotta fold here so I have something to trace, and fold here. There we go. Okay, so as I keep going, then this one is going to be 4 pi over 6, which is going to reduce to 2 pi over 3, and that should match up on the orange layer. If I lay those back down again. So see how when we put this on here, we've got 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6 lines up with 2 pi over 3. Guys, I'm recording a video. Baby, you gotta go with Poppy so Nana can finish teaching. Bye, baby. Okay, so 4 pi over 6 corresponds with 2 pi over 3, and then if I keep following that pattern, that's going to be 5 pi over 6 here, and then 6 pi over 6, which if we slide that over, we see that reduces to 3 pi over 3, which reduces to pi. So see how some of these special angles, as we count around the circle, they're all going to line up with each other when we put all these layers together onto that big unit circle template that I gave you last week. Okay, so if we continue now on the bottom half of our purple layer that has 12 sections, right, we just did the first 6 sections walking across the top here: 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. So this now is 7 pi over 6, then 8 pi over 6, which reduces to 4 pi over 3. Then we have 9 pi over 6, which reduces to 3 pi over 2. Next comes 10 pi over 6, which reduces to 5 pi over 3. And then 11 pi over 6, which reduces, doesn't reduce, sorry, and then 11 takes us back around to 12 pi over 6, which is the same as 2 pi. So that's one whole wrap around the circle because there's 2 pi radians in the whole thing. Okay, so those, thank goodness, are all the special angles on your unit circle. And when you put all those layers together, when you overlap your 4 quadrants, right, with your 8 quadrants, which was the green layer, that was sectioning off this in 8 sections, your 6 section layer, and then your 12 section layer, right? All those angles that we just looked at in all those layers are where this comes from, which this is that unit circle template that I emailed everybody last week. Oh, I guess it's upside down. Emailed everybody last week and asked them to either copy or copy down onto paper so that you could fill it in as you were watching the video. So gonna pause here because we're at 20 minutes already on this one, and then when I record the next one, we'll go ahead and tackle tricks for filling this out and then figuring out the coordinates.